Hello all, welcome back to my YouTube channel all about VLSI. Hope you're all doing good. Good evening everyone. Yeah, so let us start today's session. So before starting the session, please make sure that you have subscribed to our channel all about VLSI, right? Yeah. So today's topic is polymorphism. So today we are going to start with a topic called polymorphism. It is a very important topic that we are going to discuss. Okay. Yeah. So before starting the session, please make sure that you have subscribed to our YouTube channel all about VLSI. Okay. Yeah. So let us start today's session. I hope my voice is audible and my screen is also visible. Right. So in previous session, we have discussed about static properties, static methods, all these things we have discussed, and we are actually discussing about inheritance. So polymorphism comes in the topic called inheritance only. Okay, so actually we are discussing this concept. Okay, and share this video to all your VLSI friends who are interested in this VLSI. Okay, so please share to them also so that they can be also get benefit from this free sessions of SystemVerilogs. Okay, I think we have almost completed 30 sessions on this particular SystemVerilog. Okay, yeah. So let us start today's session. So we will start with the topic called polymorphism. Polymorphism. So what is polymorphism? Anyone? Any idea? Any thoughts or any ideas? You can post me in the live chat. Yeah. So what is polymorphism? Polymorphism is nothing but a single object, okay, a single class object can at a time act as a parent class, can act as a parent class, as well as it can act as a child class. A handle, a class handle can act as a parent class handle as well as child class handle. That is nothing but polymorphism. In simple terms, in lame terms, if I want to define what is polymorphism, this is the definition. A class handle can act as a parent class handle as well as a child class handle. That is meant by polymorphism. That's it. This is a simple definition. If you want to explain someone what is meant by polymorphism, you can tell them a class handle can act as a parent class handle as well as a child class handle at a time. It is called as polymorphism. Poly means many. Okay, the name itself indicates many. Okay, so polymorphism, a class handle can act as a parent class handle as well as child class handle at a time. Okay, so how it is going to act, everything we are in this session we are going to discuss it now. Okay, let's start the discussion. Let us consider a parent class. Let's say class example underscore parent. Let's say ex underscore parent. Okay, so this is our parent class and it has some task. Okay, let's say task some any task, let's say add. Okay, so this is our task or method, you can say. Okay, and we have some logic written inside that and ending the task. Okay, we have some logic inside that and we are ending the task. Now let us take another class which is extending from our parent class. Let's say this is ex underscore child extends from ex underscore parent. So if you haven't watched the previous sessions about this, what is meant by parent class and what is meant by child class, I suggest please go back and revisit those lectures because it is very important to understand what is meant by this inheritance. Then only you can understand polymorphism. Okay. So if you are new to this video, so please don't watch this. Please go back and rewatch the sessions where we have discussed about inheritance. Or if you already know about inheritance, then no problem. You can continue. Okay. Yeah. So here this child class ex underscore child is being extended from ex underscore parent. So ex underscore child is a child class of ex underscore parent. Okay, ex underscore child is a child class of parent class ex underscore parent. So it is being derived from our parent class, and it also have its same task name task add. Okay, and it has also some logic written inside that, and ending the task. Ending the task. So in previous session when we were discussing this particular methods, so let's say if we declare handle for this ex underscore parent as ex underscore parent as p underscore h and child as ex underscore child c underscore h. Okay, so when we were discussing this, what we have discussed, so for example, if I access p underscore h dot add, so it will refer to the parent class method. Okay, so this method will be called. Okay, p underscore h dot add, then the parent class method will be called, and c underscore h dot add child class method will be called. Okay, I think up to here we are clear. So what happens if we call p underscore h dot add, so this method is being called, and c underscore h dot add, this particular method will be called. Okay, so basically what we are doing, we have created parent class handle as p underscore h and child class handle c underscore h. And sorry, first we should create the object. So after creating the handles, we should create p underscore h is equal to new and c underscore h is equal to new. We should create the objects for these handles, then only we can access those methods. Okay, otherwise we will get error called null reference handle. Okay, like that error we will get. So first we should create the object, and after creating the object, we are calling the method which is present in parent class, and we are calling the method which is present in the child class. Okay, just we are calling the parent class method and child class method with the parent class object handle and child class object handle. Okay, up to here I think it is clear. Now what if I perform this operation? Okay, let's take two scenarios. Let's say two scenarios. This is scenario number 1. Scenario 1. This is scenario 2. Okay, let's take two cases. One is scenario 1 and scenario 2. Okay, so in the first case, what I will do, I will assign c underscore h is equal to p underscore h. And in the second case, what I am doing, p underscore h is equal to c underscore h. Okay, so what is first case? Parent class handle is assigned to child class handle. I will write it here. So in the case 1, what we are doing, parent class handle is assigned to child class handle. Okay, parent class handle is assigned to child class handle. That is, child class is pointing to parent class object handle. Okay, that is case 1. And in case 2, child class handle is assigned to parent class handle. So in the case 2, child class handle is assigned to parent class handle. That is, parent class is pointing towards the child class object. Okay, so these are the two cases. But in OOP, in the object oriented programming, there is the rule that only child class handles can be assigned to parent class handle. What is the rule? We have only child class handle can be assigned to parent class handle. Only this is possible. Only child class handle can be assigned to parent class handle. Okay, this is the rule which is present in the OOP, object oriented programming. Only child class handle can be assigned to parent class handle, but vice versa, that is, parent class handle cannot be assigned to child class handle. That is, the case 1 is not possible. Here we will get a error when we try to assign a parent class handle to a child class handle. So here, if we try to perform this type of operation, when we try to assign a parent class handle to a child class handle, then we will get a compilation error. Okay, that we will see when we are doing coding. I will show you how when we try to assign this type of when we try to make this type of assignments, we will get an error. I will show that error also. Okay, so this type of assignment is not possible in object oriented programming. What type of assignment? Parent class handle cannot be assigned to child class handle, but vice versa is possible. That is, child class handle can be assigned to a parent class handle. That is, the scenario 2 is a possible scenario. Here we will not get any error, but here in the first scenario we will get a error. We will get a compilation error that saying that parent class handle cannot be assigned to a child class handle. Okay, so remember this. Don't try to assign any parent class handle to child class handle. Okay, don't try to make this mistake. Okay, this can be possible in some other cases when we use $cast that I will show. Okay, so for now, don't try to make this type of assignments. Okay, now, so this is the OOP rule that we have seen. Now, for this particular example, we have started discussing where we have a parent class ex underscore parent and child class ex underscore child. Okay, which has been derived from ex underscore parent. Okay, now let us try to assign child class to parent class. Okay, how to assign child class to parent class? P underscore h. First I should create the objects. P underscore h is equal to new and C underscore h is equal to new. After that, what I will do? P underscore h is equal to C underscore h. Okay, I am assigning my child class to parent class. Okay, and what I am doing? I am assigning my child class to parent class. That means parent class is now pointing to child class object. That means the parent class is now pointing to child class object handle. Okay, now what I will do with the help of this parent class handle, I will try to call the method p underscore h dot add. Now, which method will be called? Whether the method which is present in the parent class or the method which is present in the child class, which method will be called? P underscore h dot add. If I am calling after assignment, which method will be called? Whether the parent class method will be called or the child class method will be called. Which method will be called? Any idea? Any guess? Any answer in the chat box? So if we try to assign, if we try to call the method with the parent class handle after the assignment p underscore h dot add, so the method which is present in the parent class only will be called. The method which is present in the parent class will only be called. But what we think, so hence we are making the assignment p underscore h is equal to c underscore h, and since the p underscore h, that is a parent class object handle, is pointing towards the child class object handle, so what happens if we call the method with the help of this p underscore h dot add? So what we think, the method which is present in the child class will be printed, because the method which is present in the child class will be called because this parent is pointing towards the child, so it will become as it will work as a child class object handle. So that's why if we call this method with the help of p underscore h after this assignment, the child class object will be called. Like that we will think, but it will not happen. Okay, so that is what it is happening. So polymorphism is not happening. What is polymorphism? This parent class handle should work as a child class handle. Okay, that is meant by polymorphism. The parent class handle should work as a child class handle. But here it is not happening. After the assignment also, it is not happening. Okay, so the parent class handle is not working as a child class handle. But what we want, this parent class handle should work as a child class handle. That is meant by polymorphism. Polymorphism is nothing but same handle will work as a parent class as well as a child class. Okay, but it is not happening. So to perform polymorphism, we will use a keyword which is called as virtual. We will use a keyword called virtual. So the virtual keyword in SystemVerilog is used to define methods that can be overridden in derived classes. Okay, so we use this keyword virtual to obtain or to perform polymorphism. So when a method is marked as virtual, SystemVerilog enables runtime polymorphism by ensuring that calls to this method are resolved based on the actual object type, not just the handle type. Okay, actual object type, not just the handle type. Actually, in the previous case, what is happening? P underscore h is equal to c underscore h. We are assigning child class to parent class. Parent class is pointing to child class, and what we think, we have made the assignment. So if we are call the object with the help of p underscore h handle, we will print the child class object. That is what we are thinking. But compiler will not accept that. Compiler will think p underscore h is a parent class handle. So the method which is called by the parent class handle only will be printed. That is what the compiler is going to think. So to avoid that, we are going to use the keyword which is called as virtual. We are going to use the keyword which is known as virtual. Basically, this virtual is a virtual enables runtime polymorphism. Okay, virtual keyword enables runtime polymorphism. Runtime polymorphism. Okay, by ensuring that calls to this method are resolved based on the actual object type. Okay, actual object type. So basically, this virtual keyword defines overridable methods. So a virtual method is a base class can be overridden by derived class, allowing them to provide their unique implementation. Let us see how this virtual keyword now help us to attain this polymorphism. Okay, so let us consider the same example where we have taken in the starting case class ex underscore parent, class ex underscore parent. I will write it here, class ex underscore parent, and this task, instead of writing it simply, I will use the virtual keyword, virtual task add. I will write my logic here and ending the task. And class ex underscore child extends ex underscore parent. Okay, virtual, here also we should declare the virtual task add, and we will write the object and ending the task. Now what happens? Now let us create the handles ex underscore parent, p underscore h, and ex underscore child, c underscore h. And let us create the object for this. P underscore h is equal to new and c underscore h is equal to new. Okay, like this I am creating the objects. Now I will assign p underscore h is equal to new. Sorry, p underscore h is equal to c underscore h. That is child class. I am assigning it to p underscore h. Now if I call p underscore h dot add, then which method will be called, whether it is going to refer to the parent class method or the child class method. So in this case, it will refer to the child class add method. Child class add method. Since we are using the virtual keyword, the compiler will come to know that here the assignment has been happened, and this parent class handle is, since it is pointing towards the child class handle, so the object will be the method of the child class will be printed, or the method of the child class will be called because we are using the keyword virtual. Okay, so with the help of this virtual keyword, we can able to achieve the polymorphism. How the parent class handle is now acting as a child class handle. Why? How it is acting? So when we call this method p underscore h dot add, so the add method in the child class is being called. So therefore, this p underscore h is now acting as a child class. So this is how our virtual keyword help us to achieve polymorphism. Here the parent class handle is now acting as a child class handle. Okay, so with the help of this virtual keyword, we can able to achieve our polymorphism. So if you use this virtual keyword, then we can easily override the methods. So we can able to override the method of parent class by the child class, and we can also able to achieve the polymorphism. Okay, so this is how the virtual keyword works. Okay, yeah. So that is about the virtual keyword and the polymorphism in SystemVerilog. I hope this example is clear and this concept is clear, right? So if you are having any doubts or queries, you can ask me, or else we can end the session. So in next session, with the help of coding in the Testbench software, we will see how to achieve this polymorphism. We will take one example. Same example we will take, and we will try to understand it more clearly. I hope now, up to now, till now, you got a clear idea about polymorphism. Yeah. So that's all for this session. So if you like this video, please like, share, and subscribe to my YouTube channel all about VLSI. Thank you.